Hello, today we're going to talk about squares, cubes, and square roots. Alright, first, squares. When I say I'm going to square something, that means I'm going to multiply it by itself. So if I square 2, I'll do 2 times 2, which gives me 4. The other way to write this is with an exponent. So if I say 2 squared, that's the same way saying 2 times 2, which equals 4. So I could do it with any number. I can say 7. 7 squared. What 7 squared means is 7 times 7. Can do 15 squared. That means 15 times 15, which is 225. So that's what squared is. When you say squared, it's just a generic name for saying something to the second power, right? Just like addition has subtraction and multiplication has division, squaring has square rooting. They are called inverse operations. So if I square the number 5, that gives me 5 times 5, which is 25. Now, if I want to square root a number, take 25. When you square root a number, you're looking for something that would actually make a real square, like a 5 by 5, 4 by 4, stuff like that. You're looking for the same number multiplied by itself. So in this case, 5 times 5, which gives you a number. So 5 square root, or 25 square root, is 5. So 5 squared is 5 times 5 equals 25. The square root of 25 is 5. Inverse operations. So let's do another one. So if I took 4, and I said I'm going to square root 4. The square root of 4 is 2. So if I want to do the inverse of that, I would do 2 squared equals 4. Inverse operations. This 4 is what is called a perfect square root. When you square root 4, you get out a whole number with no decimal, which is what a whole number is. So you'll get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for all eternity, or infinity. Now, you should know perfect square roots from about 1 to about 15. That's your ideal number, but they're called perfect square roots. Another example of this. So if I say 64, which is a perfect square root, the square root of 64 is 8. So if I wanted to know what 8 squared was, it would be 64. Inverse operations with square and square root. So perfect square root is a number that is square rooted and it comes out as a whole number. So the square root of 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6. I'm not going to go on forever because you can just look it up. I would memorize from about 1 through 15 is real good to know. If you can get 1 through 12, that'll help too. But anything outside a perfect square root, all perfect square roots are called rational numbers. Anything that is a square root that is not a perfect square root is called irrational. So perfect square roots are rational because they come out with their whole number. But if I did the square root of 26, that is not a perfect square root and is irrational. And by the way, 26, if I asked you what terms it comes in between, you would say 5 and 6. It's still irrational, but it becomes between 5 and 6. Now what if I said the square root of 6? Is that a perfect square root? No. So it is irrational, and it comes between 4 and 9 or 2 and 3. And that's how you find which terms it's in between. You just know your perfect square roots and see. All right, so cubes. Squares are 2. So if I square root something, it's 2 times 2. 2 squared is 4. Cubing it is a number to the third. 2 times 2 times 2, which is 8. All you're doing, all it is a generic term again for something raised to the third power. So 3 cubed is 3 times 3 times 3, which is 27. It's the same thing with cube rooting. Cube rooting, if I want to know what the cube root of 27 was, it would be 3. The cube root of 8 is 2. A cube root is written like this. And the cube root of, there you go. All you're trying to find there is what number is multiplied 3 times to get 27. What number is multiplied by itself 3 times to get 8. And that's what a cube root is. All right, this has been squares, square roots, and cubes. I hope it helps out, and good luck.